Hello everyone. So I'm going to talk about explaining about question 1 and question 7 for these CBT questions. So firstly, I will explain question 1. Question 1 says that this company has a current price of S0 and its volatility is 12%, which is the sigma is 12%, and the dividend is 1%. And the stock price follows the binomial model with 36 period 1 month each, and is given that R is 7.4% per annum. So the question asks us to determine, in part 1, the question asks us to determine the price of stock at 0, which is the S0, if the price at 0 of a 3-year 42 strike American call option is 10.93770181. And for part 2, by using the value in part 1 of the value of S0 in part 1, construct a binomial tree with 12 period and then determine the price of a 1 year at the money European put option on the share of this stock. And for part 3, using the same value as well in part 1 to construct a binomial tree with 18 periods and approximate the value of delta and gamma for the European call option. So firstly, I list down the data given, which is there are 36 period. For part 1, there are 36 period, and then the K is 42, sigma is 12%, R is 7.4%, delta is 0.01, and to find H is actually 1 divided by 12. And to find U, actually exponential power R minus delta times H plus sigma times square root of H. And to find D is actually exponential power of R minus delta times H minus sigma times square root of H. So to find P, the formula of P star is actually exponential power R minus delta times H minus D divided by U minus D. And 1 minus P star is actually equals to Q star. And I write down the steps from 0 until 36, which is 36 periods. And to find the binomial tree of stock, which is the S. So basically in the period 0, which is the value we are going to find, equals to this cell C4. And to find a binomial tree, the formula to find the next value is actually the current S0 times U. And so the value going upwards is S0 times U. And the value going downwards in the binomial tree is S0 times D. And this whole formula is actually for me to convenient to drag everything in Excel. So the formula for period 1 until 36 is all the same. So I just drag the formula from here to here until 36. And I drag everything down until here. So this is how I get the binomial tree of stock. And the question gives us the question asks us to find the value of S0 and is given that the call option is 10.93770181. So firstly, I construct a call option binomial tree, which the formula is the maximum exponential negative R times H times the P star times the next value going up plus the 1 minus P star times the next value going down. And if to find the next value, so it is basically the maximum of S0 minus K, S0 minus K. So this whole thing is also for me to convenient to drag in Excel. So I'll drag from here to here, but not until the last column because the last column has another formula, and drag everything down until here. So for the last column, the formula is actually, because this is a core option binomial, which core option is actually S0 minus K, which is this one, S0 minus K. And then I drag everything down until here. So to find S0, I use go-seek formula. And then I set the value of core to the value given in the question, which is this one. And by changing the cell which we want to find, and I'll let the Excel to run to find the answer. So finally, I will get the answer of S0 is equals to 45.58621,237. So this is how I determine the value of S0 in part 1. So for part 2, since the part 2 says that is 1 year at the money European put option, which means that S0 and K have the same value. And the information, the data is basically the same as part 1. But part 2 asks us to only construct a binomial tree of an European put option for 12 periods. So this stock binomial tree is actually the same as the above one, which I just copy down until period of 12. And to find put option, the formula is actually just same as the call option, which is the next value going upwards times P star plus the next value going downwards times 1 minus P star times exponential negative R times H. So to get a put option, and I'll drag everything from here to here. Oh, sorry. From here to here, except the last column, and from here to here. The last column is actually the same as the call option, but since this is a put option, the formula is K minus S0. And then I'll drag everything down until here. So this is how I'll get. Finally, the put option, the value of put is 0.96530165. And for part 3, the informations are here. Part 3 asks me to construct 18 periods. So the stock biometry is the same until 18 periods. And for call option, it's actually basically the next value times the next value going upwards times P star plus the next value going downwards times 1 minus P star times exponential minus power minus R times H. So I'll drag everything until here as well. And this is a call option, so it's actually S0 minus K. I drag everything down here. So I construct a call option binomial so that I can find the delta, which is exponential power minus delta times H times Cu minus Cd divided by Su minus Sd. And then delta I will get 0.754643051. And to find gamma, firstly I have to find the up node delta and down node delta, which is the up node delta's formula is exponential power minus delta times H times CUU minus CUD divided by SUU minus SUD. And for down node delta is actually exponential power minus delta times H times CUD minus CDD divided by SUD minus SDD. And the gamma formula is up node delta minus down node delta divided by SU minus SD. So at the end, I will get 0.0455629795. So this is how I do question 1 for all three parts. Next, we move on to question number 7, which a London-based fashion designer is expecting to receive 100 million from a Japanese company as payment for goods sold in 1 year. Concerned about potential exchange rate fluctuations, the company decided to hedge its currency risk by purchasing an option that grants the right to exchange yen for pounds at a rate of 0.0055 pounds per yen. Then given the information here, which is the spot exchange rate is 0.005 pounds per yen, the sigma is 0.08, the R risk-free rate for yens is 0.0055, 0.055, the risk-free rate of pounds is 0.035. So for 7a, the question asks us to calculate the cost hedging using 12-period binomial using two distinct approaches, which is pound denominated and yen denominated. And for part 2 is to calculate the price of the option by conducting a Monte Carlo simulation of 100,000 interaction. So for question 7, I list down, firstly I do the pound denominated, which I list down all the informations given here, and then the H is basically 1 divided by 2, 12, and U I mentioned earlier in question 1, which is exponential power R minus, since this here has two R's, so I use the R of pound minus R of yen times H plus sigma times square root H. And to find U is actually the exponential power R pound minus R yen times H minus sigma times square root of H. And for P star, the formula is exponential power R minus H times R minus R pound minus R yen times H minus D divided by U minus D. And 1 minus P star is just 1 minus this one. And for this, the period is 12. And the stock is 0.005, which question given. And then by using the same equation in question 1, which is to find the value going upwards is the S0 times U, and to find the value going downwards is S0 times D. And so I drag everything down here until here, and then I'll construct the stock binomial tree. So to find the put binomial tree, the same formula I mentioned in question 1 also, and then I drag everything from here to here, and then from here to here. And for the last column here, since it's the put, so it's k minus s0. Then I drag down. So I'll construct a put binomial tree. And then after I construct a put binomial tree, I can find the cost of hedging, which is the put times the 100 million. And then I'll find cost of hedging for pound denominated, which is 59216.29285. Next, I'll find yen denominated, which is the call, and then the information for 12 period. And then the S0 is actually 1 divided by the 0.005, because the yen denominators is actually pound yen per pound. So I have to divide 0.005. And then the R yen is 0.055. The R pound is 0.035. The sigma is remain the same. The H, everything are the same as above. And then to find the stock binomial tree of yen denominated, which is the stock is 200, and then using the same formula as above and also question 1, and then I drag everything again, and then I'll construct the stock binomial tree. So to construct a core binomial tree is the same formula I explained just now, which is the next value of call option times P star plus the next value going downwards times 1 minus P star times exponential minus power minus R times H. And then I'll drag everything again until here and until here. And then for the last column is the maximum of S0 minus K. And then drag everything down. To find the cost of hedging of this is actually 100 million divided by C20, which is K. So this is based on yen per pound and times the core value I found here. So at the end, I will get 1184325.8.57. So this is how I do part A. So for part B, the information is given here as well, and then I just write it down, and then T minus T is actually equals to 1. So to do by running using Monte Carlo, the steps from 1 until 100,000, and then U is actually using the formula of random number, which is this one. And then to find Z score is actually the standard normal interval of U. And then the exchange rate is actually S0 times exponential of R pound minus R yen minus 0.5 times sigma square times T minus T plus sigma times square root of T minus T and times the Z score. And then I drag everything down, I drag everything down until 100,000 here. And to find the payoff is actually the maximum of exchange rate minus K. And I drag everything down again until 100,000. So I'll get the expected payoff is actually the average of the payoff from here, step 1 until step 100,000. And then to find the price option is actually the expected payoff times exponential power minus R pound times T minus T and times 100 million. And at the end, I will get a random number generated by the Monte Carlo in Excel. So this is how I do question 7. Thank you very much.